So for NAE4, I am talking about how microgravity and its effect on plants, and how my personal design to solve the problem that is caused by microgravities and the effect it has on plants. Moving on to the problem at hand. Plants on the ISS are facing many growth defects due to numerous reasons because of the effects of microgravity. On Earth, plants face a stronger force from gravity and are able to flourish as the gravity allows these plants to grow in optimal conditions. Furthermore, plants are often reliant on gravity as the way their stem and roots grow are reliant on them. However, in space, microgravity often creates defects on the way plants are grown, as it tends to push the growth in stems in numerous different ways that are not very beneficial to them. Furthermore, the biggest problem, the problem we are mainly targeting, is how microgravity affects how plants receive one of their main nutrients, water. At the moment, water is extremely hard for plants to receive due to the nature of water and microgravity, causing the plants to gain an insufficient amount of water and thus grow insufficiently. In this project, we are primarily focusing on finding the effects of microgravity to help crops grow as efficiently as possible. With the lack of gravity on the ISS, crops are often growing their roots and stems in defective ways that do not allow it to grow as efficiently as needed. Along with that, solutions are needed to help plants gain water in this microgravity environment. As a result, there are numerous ideas and designs that can be created to help fight this insufficient gathering of nutrients. My design is just one of them. In this project, we are primarily focusing on finding the effects of microgravity to help crops grow as efficiently as possible. With the lack of gravity on the ISS, crops are often growing their roots and stems in defective ways that do not allow it to grow as efficiently as needed. Along with that, solutions are needed to help plants gain water in this microgravity environment. As a result, there are numerous ideas and designs that can be created to help fight this insufficient gathering of nutrients. My design is just one of them. For my design, I am simply adding a pressure tube that leads water directly to the soil. By doing so, we can have control on where we send the water and help manipulate the amount of water a plant can receive. Moreover, we can also control the amount of force we're sending into the spaces where the roots are at and help the plants gather more water by doing so. By doing this, we can help fight the lack of water plants naturally get in microgravity and allow plants to receive more water than they naturally would in this unique environment, in microgravity. Naturally on Earth, water tends to fall to the bottom of the soil where the roots can reach it. However, in microgravity, the water tends to fill the outskirts of the soil, which is out of the reach of the roots. Because of this, many plants tend to have insufficient amounts of nutrients and thus grow in defective ways. In the next drawing, I drew a rough model of the pressurized tube and tank that is sending water to the soil. The drawing demonstrates a simplistic take on a pressure tube and tank for a single plant, meaning the model obviously gets more complex as the more plants or the more variables there are. In this drawing, we can see the pressurized tube that is sending in pressurized water to the soil of the plant, forcing the water to where the roots are, allowing them to have contact to water whenever required. The pressure tank itself can have a simple design of pressured air that pushes the water with more force. This causes the tank to send in pressure waters that can counteract the effects of microgravity on water, meaning that rather than water just surrounding the outskirts of the soil, we can specifically send the water at a specific location, i.e. the roots, and so that the plants can get water. Furthermore, there is a filter that serves as a means to filter out excess water that isn't intaken by the roots and can be recycled to be used in the pressure tank again. It is important to note that the pressure cannot be too strong or it may hurt the roots of the plants, or that too strong of a force will cause the roots to struggle in intaking the water. Furthermore, we can move on to comparing my design to the design team criteria. The first thing we can look like on the criteria is utility, or how well does my design fix the problem of microgravity effects in space. My design solves the main problem, in which is that it gives plants a means to receive water in a consistent manner and fights the problem of how plants receive water in a natural state of microgravity. Because of this, I do give my design a 4, as it does solve the problem at hand, in which that it allows plants to receive water. The next thing we can look at is the durability of my design, which shows a limitation of my design, as because of the pressurizing tube and tank, we are consistently adding force on it every time we use it. Because of this, I believe that my design deserves a 2 or a 3, in which it survived from 5 to 10 years in that time span. I believe it can survive 5 to 10 years because as we continue to use it, people will continue to use maintenance on it and continue on using it. However, even through maintenance, it can only survive for so long through all that pressure and force that I give an estimate to 5 to 10 years. Continuing on, we can talk about the cost efficiency of my design. Here, I believe my design shows a major limitation in the price of it, as it may cost between 500k to $1 million. A big reason of this pricey cost is that to consistently use force on the model, we're going to need pretty durable material. Furthermore, if we're going to use this on a wide spread, we're going to need more money. This really ties hand to hand to the durability of it. If you want it more durable, then we're going to cost more. If it's less durable, it's going to cost less. There seems to be a correlation, but that's the design of it. Moving on to safety, I believe that this pressurized tube can be relatively safe, because in the whole grand scheme of it, we're not pressurizing water at an extreme level, but just enough for us to counteract the effects of microgravity. Furthermore, the pressure is not really that strong because we cannot send that strong of a pressure to the plants, as it may hurt the roots or cause some sort of problem of the plants in taking the water. Because of this, the safety is relatively good, and then I believe that my design deserves a 4, as I believe anyone in the ISS can use it safely. And last is sustainability. Here, this also ties into the limitation of durability and cost efficiency, as if we were to create more quantities of this to support a large population, we're obviously going to need more money and then more durability to sustain such pressure and whatnot.